Hello, how are you? How are you doing? It's uh, it's me, the pioneers in Memphis. Today we'll make a live stream, okay? And now I'm live. So the title of our live stream presentation has to be exact symbolic roots of 12 degree polynomial beyond classical and AI methods. Let's make our introduction. Our introduction. So we can say that. Welcome everyone. I am Professor Mourad Sultan Ezouidi, and today we are diving deep into solving the 12-degree polynomial equation, the case that all classical algebraic methods fail to solve exactly. Today we will see that Cardano or Ferrari or Lagrange and Galois methods break down. Abel's impossibility theorem declares it insolvable. Even modern AI systems like Wolfram Alpha or ChatGPT can produce exact symbolic roots. But using Ezouidi theorem, we will not only solve this equation, but extract 12 symbolic roots with precision. So the equation, I will first share the screen. I will share the screen. Okay, okay, and okay, share. So we call that uh, the equation. We start with the 12-degree polynomial equation. Okay, just a moment here. I will share the screen with you. Okay, so we told that here is our 12 degree from the equation. We'll begin with the equation P of x equal x raised to the power 12 minus 24 x raised to the power 11 plus 264 x raised to the power 10 minus 1760 x raised to the power 9 plus 7920 x raised to the power 8 minus 25,344 x raised to the power 7 plus uh, plus 14,219,778 x raised to the power 6 up to the last coefficient is 1 plus 5I equal n. Okay, here you see the key idea of my Mourad Sultan's theorem is the systematic generation of root structuring coefficient sk of order r using a recursive summation involving L subscript k of order r, the reduced coefficient of the polynomial. So the core recursive formula is that S subscript k minus 1 of order r equals the sum from 0 to k combination n minus r choose k minus r n raised to the power r between parentheses negative 0 for the q raised to the power k minus r times lr minus 1 for the q. So this is in theorem. Okay. So here you can see that this expression is this expresses, let's say, its symbolic coefficient sk minus 1 for the r in terms of elevated and binomial structure. It transforms the polynomial into a form that reveals its root symmetry. So here, my professors and colleagues and those who have smart minds, I'm going to ask a question: why uh, classical methods fail? This is the first question that I'm going to question to ask for you. First of all, you can see Abel-Darfini theorem says general polynomial of degree 5 or higher can be solved with the radical. Galois theory also confirms its for symmetrical group structures. Numerical method like Newton Raphson or only approximate roots. AI, artificial intelligence, algebra systems like Wolfram Alpha, Sage Math, and Mathematica give decimal approximation, not exact form. Today, we symbolically solve this using Mourad Sultan Ezouidi theorem. Means we'll apply this theorem. Okay. So here is the theorem structure. The roots are derived from the recursive symbolic formula as subscript k minus 1 equals the sum from 0 to k combination n minus r to k minus r n raised to the power r between parentheses negative 0 for the q raised to the power k minus r times r minus 1 of all the q. Here, professors will compute, let's say, symbolic coefficient, okay, sk of order r as follows. We have here S0 is going to be equal to 0. Of course, S minus 1 is going to be equal to 1 away because different to 1. S0 is 1. S1 is equal to 0. S2 is equal to 0. S3 is equal to 0. S4. Okay, but S5 will be 13,962,842 raised multiplied by 12 raised to the power 6. Then we compute symbolic coefficient Sk as in the formula. I will obtain that S6 is equal to 0, and S7 is equal to 0, S9 is equal to 0, S10 is equal to 0, except S11 is different to NL, which is equal to 12,517,210,881 plus 5I. You see the imaginary, the last coefficient of my original 12 degree equation times 12 raised to the power 12. So here we can see that we reduce the polynomial P of x as x raised to the power 12 plus S5 x raised to the power 6 plus S11 equal 0. Now let's extracting the roots structure. We define my discrement when k equal when n equal to S1 of order q dash equal negative S5 of order q squared plus 4 times S1 of order q. So this one is written like that. Okay, this is the value of the discrete result, x raised to the power 6y, simply because we reduced our polynomial to what? To x raised to the power 12 plus s5 x raised to the power 6 plus s11 equal to now. Okay, here after making x raised to the power 6 equal negative s5 of 42 plus negative root of negative s1 of 42 dash divided by 2. So xk has to be written as that. Okay, this is the value of sk, where k belongs to the set of numbers from 0 to 5, because this is plus negative. We have 12 x roots of these new 12-degree column equation. Then the prime roots of the original 12-degree column equation are in fact written as that alpha subscript k is equal to L042, which is 24, plus xk divided by 12. This will give you 2 times 2 plus between parentheses 6,981,421 plus negative the value of this discriminant divided by 4, all raised to the power 1 over 6 exponential 2k plus 1 pi divided by 6, where k here is going to be equal to 0, 1, and 2, 3, 4, and 5. Okay, so we've obtained conclusion. We have obtained the exact roots, exact symbolic roots, verified that no classical methods or AI could yield these forms. Mourad Sultan Ezouidi theorems of the new era of symbolic computation. New era of symbolic computation. Okay, so stay tuned for more groundbreaking examples and join the revolution in mathematical thinking. Thank you, my colleagues. So this is the example I solved it, and thank you for listening. See you next time. Okay.